Good morning, everybody. We're going to be working on page 54 today. And we're going to be focusing on still using area models and multiplication, but now we got to show that with equivalent fractions. So we just have to prove that the equivalent fraction is correct. So let me zoom in on these four here. And I'll give you an example really quickly of what we'll be working with here. First, they want us to draw an area model. Okay, so we're going to draw an area model of 2/5. Okay. All right, I got 2/5, and I'm going to shade in 2. Okay. Now, I am going to rewrite this problem on the side here. And what we need to realize really quickly is what multiplication, what multiplication are we using in order to multiply 2 times what equals 4, 5 times what equals 10, right? It's got to be the same number. And once we realize what it's being multiplied by, this really helps us understand how many rows we're making here. So 2 times 2 equals 4, and 5 times 2 equals 10. And so we're going to make, we're going to cut it in half here, and we will have 4/10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we have 1, 2, 3. We have 4 shaded. So that does equal 4/10. So this area model is accurate, and it does show us, the correct area model for this fraction. So let's start with B, and then I want you to do C and D on your own. Okay. So let's go with B. We still need to make an area model of 2/3. So let's make an area model of 2/3 here. All right, and let's shade in 2/3. Excellent. And I'm going to just rewrite this on the side here so that we have, so we can see what's kind of going on with this problem. Remember, we're using multiplication, and we got to find out, hey, what are we multiplying here so that we can figure out the amount of rows we're using. Well, 2 times what equals 8? And I know that 2 times 4 equals 8, and 3 times 4 equals 12, because it's being multiplied by the same number, the numerator and the denominator. So I'm going to make 4 different rows here. 1, 2, and 3, right? We got 1, 2, 3. We got 4 rows. Now let's make sure that we are accurate here. Well, I got 1, 2, 3. So I got 3, 6, 9. I got 12 altogether. So I do have 12. And I have 1, 2, 3, 4, 5. I have 8 shaded. So yes, it does equal 8/12. Perfect. All right, I'd like for you to do C and D on your own, making those area models, showing the multiplication that is happening with our equivalent of the 2 fractions. And so pause the video, and when you start over again, we're going to be working on using this multiplication now to find out what it's being multiplied. So here, we're just going to be using multiplication to find an equivalent fraction, and they didn't give us equivalent fractions here. Instead, we're going to make our own. And all we need to do is, so I have 3/4, and I'm going to put that equal sign, put 3/4 again, just like we practiced yesterday. And we can multiply this by anything we want to. I'm going to do 3. And that'll be 9/12. So these two are equivalent. Okay. Try B, C, and D. and just multiply that by the same number using your numerator and denominator, and you'll find your same equivalent fraction. All right? Okay, I am going to go on to 5A, 5B, 5C, 5D, and I pause the video so you kind of know what you're doing. You saw those that we just worked on, and when you get back to it, you'll be back here with me. All right, so for the next portion here, we are going to determine which of the following are true number sentences. All right, and a number sentence is just this. It's a math sentence. Is it true? Is it not? And we're going to be correcting those that are false by changing the right-hand side of the number sentence. Okay? Perfect. So here, I'm going to rewrite it so that we have, I'm going to rewrite it here so that we just have it rewritten. And I know they're saying it equals, they're saying that it equals 8/9. Okay. Now, is this true? Well, let's work with it just a little bit. So, what if so I know that 4 times 2 equals 8. What about 3 times, and remember this has to be 2 as well, but 3 times 2 doesn't equal 9, right? So this is false. This is actually very false. Instead, this 8/9 should change, and it should change to 8/6. Okay, 8/6, and this is an improper fraction, but it doesn't matter. It's still equivalent, meaning that we are still taking the same amount out, but we just need it to be equivalent here. It was not equivalent because it had 9, so it was 3 times 3. So that's why. So let's go on to B, see if this is true as well. So I'm going to rewrite it. So 5/4. 5/4. It's going to be multiplied. And they said that it equals to 10/8. Well, I know 5 times 2 equals 10, and 4 times 2 equals 8. So perfect. So this is true because we multiply by the same number, 2, and it did come out equivalent. So 5/4 and 10/8. So what I would like for you to do now is see if C and if D are true number sentences, and if they aren't, you have to change the second fraction to make it being multiplied by the same number so that it is equivalent. Okay? Cool. All right, everybody, I hope this is a simple problem set today. We're getting really into the thick of it. We're in lesson 8 now, and we're going straight into these fractions using multiplication. Have a good one.